Welcome back, everybody. We're going to knock out these uh, functions starting with you, or the rest of them. So this first one is yet another really cool function in Ramda. It's the unless function. And it takes a predicate function to begin with. So it takes an A and returns either true or false. And then it takes a function that's like a transformation function that takes an A and returns type B. And then it takes an A and it returns either an A or a B. So test the final argument by passing it to the given predicate function. And test the final argument. That's interesting. If the predicate is not satisfied, the function will return the result of calling the when false function with the same argument. If the predicate is satisfied, the argument is returned as is, right? So what this is like the opposite of an if statement, like saying if something is true, do it. But this is the opposite. This is saying unless something is true, do something. So let's look at this. This is a really good example, I think, and it makes things so concise. Now, I have no idea why they're using a let here. I think it's like when let and const came out, everybody's so used to variables, they just assumed they needed to use a let. But this is a safe increment, right? And it is going to say, I mean, it reads, unless the value is nil, increment. And normally we'd say if the value is not nil, increment. And then we have our double negative. So this is easier to read, I think. So I'll be using this one a lot. Um, so if we call safe inc with null, it is null. So we just get back null. Like unless something's null, increment it. Otherwise, just return the thing it is. What we got going on? Safe include log is not defined. I got rid of my log. Const log equals console dot log. Try that again. Yeah, and we get null. But if it was three, we would get four. Now, this isn't going to capture anything because if we did a string of three, uh, I guess you can increment a string of three. What if it was an array? Just an empty array. Well, that coerces it to zero and then increments that. What if it was an object? It's got to be something that can break this. Then we get not a number. Yeah. So it's a safe increment, assuming we pass something that can be coerced to a number. Yeah. So, I mean, we could go through lots of examples with this, but you know what an if statement is, and this is an unless statement. And actually, I would say unless may be more similar to when, to see if else or when or condition. Condition is or cond is like a switch statement, and if else is like a ternary. Um, and then we'll look at when. But I think this suffices what we're doing right now. So I'm going to move on, and once we get to when, we'll revisit this. The next one is unnest. And so this one has a type constraint where C is a chain. And remember, a chain is something that can be flat mapped, or chain is, there's a function called chain. There it is right there. And it flat maps something. And flat map basically maps and then it flattens. That maps something and returns a nested array, but you wanted a flat array. So it unnests that it unnests that array. so that you just have a flat array. So that's what a chain is. So it takes a chain of A's inside another chain. So that's our nestedness. And then it returns the unnested version of that, right? So very similar to flatten. It's a shorthand for R dot chain identity, which removes one level of nesting from any chain. And that's the key. One level of nesting. So if we do R dot unnest, we've got an outer array with these blue square brackets. And then we have a one, and then a nested array of two, and then a nested array of three, and a nested array inside an array. So two levels deep. If this is 0 levels deep, this is one, and this is 2 levels deep. And then so we should get back one, two, and an array of three because we're nesting one level, and we get one, two, and an array of three. And it's saying this is the same thing as chain using our dot identity because like chain is a flat map. So we're going to map our dot identity, which is going to give us back the exact same thing. But then we're going to unnest it one level. And then we get, we put a comma here. Then we get the same thing we got above. One, two, an array of three, one, two, an array of three. So yeah, so you got flatten, which recursively flattens an array. And then you've got unnest, which unnest one level. So if we change this to flatten, r dot flatten, which takes one argument, then we would get back a flat array of one, two, three. That's what that does. I'm probably not going to get to use with in this video. Um, but let's look at until. So until takes a predicate function, takes an A and a Boolean and returns a Boolean. And then it takes another function that goes from A to the same type A. And then it takes an A and it returns an A. Let's look here. So this is your predicate function, and this is an iterator function. And this is the initial value, and it returns the final value that satisfies the predicate. So this is like a short-circuiting function for a loop. It takes a predicate, this one, a transformation function, this one, and an initial value, that one, and returns a value of the same type as the initial value. This is an A, and it's going to return an A. Whatever type A is, it's going to return that same type. It does so by applying the transformation function, this one, until the predicate function is satisfied, this one, at which point it returns the satisfactory value. So this is along the lines of the if else or the unless and the when function. So, and it reads very well. So until the value is greater than 100, multiply the value by 2. And so we're going to call that function, it doesn't return a function, so returns a value. So we'll put this here that they do. Let's do 32. And we get 128. So what we're going to do is we're going to multiply this number by 2 32 times. Oh, no, we're not. It's checking the value. So we're going to take 32, multiply it by 2. We get 64. We check if 64 is greater than 100, and it's not. So we're going, and so this is like a negative, a negative context instead of like positive, like if something is true. This is until something is true. Um, so we got 64, and then 64 is not greater than 100. So we're going to multiply it again and get 128. 128 is greater than 100. So that's what we return. Cool, right? So, like, if you can remember all these, what would we do if it was an if statement? If, or we wouldn't do if, we would do like unless. We could say, and so that takes a and a Boolean, takes a and a Boolean, takes a transformation function. This takes a transformation function, but from type A to A. And this one goes from type A to B. And then they both take an A, but this one can return either an A or a B. And this one just returns an A once this is satisfied. So I think they're related, but yeah, really cool function. Um, I just need to force myself to use this a lot. Um, on purpose so that it becomes natural to pull from. The same way, like if feels very natural or a ternary feels natural to use. So that's until. And then we're going to look at unwind, which is object function. And it takes a string and it takes a key value pair where the value is an array of values. And it returns an array of key value pairs. What it does is it deconstructs an array field from the input documents to output a document for each element. The input documents, I guess, would be this V. Each output document is the input document with the value of the array field replaced by the element. Yeah, that's confusing. Let's look here. The string is a key, the key to determine which property the object should be unwound. Okay. Oh, I see what it's doing. And then the object containing the list to unwind at the property named by the key. Still know what this means. It's just complicated. And it returns a list of new objects, each having the given key associated to an item from the unwound list. Okay, that's useless. But let's look at the example. Okay, so we're going to unwind based on hobbies. And that's the string. And then we're passing key value pairs. So key value. But look, hobbies is an array of values. And that's what it's looking for here is an array of values. And so is colors. So if we run this, look what we get back. We get back an array of key values. We only passed it one object, but we're getting two back. And the reason is because we're going to unwind this property based on the hobbies. So we get back two objects in our new array with key value pairs, and we get name Alice because it's not an array. But here, instead of getting hobbies, golf, and hacking, we just get the first item in the array, golf, and then we pass colors with the two items. And then the next one, we get the same thing, colors, red and green, just like up here. Name is Alice, just like up here. But we get the second hobby. And then if we had tennis as a third hobby, we get three items back. So this is one of those, give it a data structure and it gives you back a modified data structure based on the initial data structure. Looks like we can only pass one thing in. So if we pass colors and we have to do it as a string, we're going to get two arrays. We're not unnesting the um, or not unwinding, I should say, the hobbies here. Instead, we're unwinding the colors, red and green, for red and green. Yeah, so when you need to do that, you do this. So, we've got the name of the function, and there's a fair amount of documentation that can be inferred by the name of the function. And then we've got the type signature, and that helps. And we can expand the parameters, and sometimes it describes the type signature in English. And we've got the description, and then we've got the code example. So it's what, like five things that we can use to understand? And then that doesn't work. We go to ChatGTP and we try to make sense of it there. Um, yeah, so that's unwind. And then let's finish off this video with update. So I want to spin, I want to be fresh when I get to this one. The update works on lists. It takes a number and an A, which presumably comes from this list of A's. Those are the three arguments, and it returns a list of A's. So the number is the index. It's the index to update in the list. So, if you have a list of three things, you got index 0, 1, and 2. So we're going to tell it which number or which index in the array that we want to update. And then we give it the value to exist at the given index of the returned array. So that's basically saying this is the value that we want to use to update, like the new value, the updated value at this index, and then the list that we want to operate on. And it returns a copy of the list with the value at the index replaced with X, right? So, like, we're not setting a value, we're updating a value. But actually, we kind of are setting. I think of update like where we would provide a function that would take the value of X at the index and use that to calculate a new value. So, like, if the second item in the index or the second item in the list was a number of two, I was thinking maybe we could like update it, take that number two as an X and increment the X and get three, update it. I think of this more like a set function. And there's also an adjust. So you can go back and look at that. That was covered by Chris. Um, but I see that like set is used for lenses. Um, it's the setter for lenses. So that might have something to do with it. And that works on objects. This works on lists. So it returns a new copy of the array with the element at the provided index replaced with the given value. I think that's a much more uh, straightforward explanation. When the index is less than negative list.length, or the index is greater and equal to the list.length, the original list is returned. Okay, so this is like an out of bounds thing. Like if you try, like the index can't be lower than zero, because that's the first thing. And it can't be greater than the length of the list because there's nothing there. So like it's not going to let you create a new property at the end of the list, because you could pass it something like 100 items from the end of the list, and then you would end up with a sparse array with all these elements in the array in between the original list and this like new thing. And we don't want that. So let's just look at a couple examples here. So here we want to update the first item, which is B, because this is the zeroth item, and this is the first, with an underscore. And it's going to change this B to an underscore, and we'll get back A underscore and C, I hope. Yeah, A underscore and C. Now this lets negative indexing, like the at method or the in JavaScript or the nth array function in Ramda. So this is going to operate at the end. It'll get the -1, the last element, and return it and replace it with an underscore. That's what we get. And then they're showing the out of range. So like 0, 1, 2, what if we try to set 3? What they've decided to do is just give us back the original list. And that's pragmatic. I might prefer an error, an out of bounds error. But like we don't get out of bounds errors in JavaScript. So that would be, they got to make a decision on how much they want to change things. Like they made that decision with equals, where we're going to change how equals works and the type function. Of course, the type function is not, it's a function, and the type of keyword is not a function, it's just a keyword. So these are the things they talked about internally and come up with a good decision, I think, in most cases. Yeah. And then so that leaves us with this very common Ramda function called use with. Like if you were going to learn 30 functions from Ramda and memorize them, which is probably the best way to go because you could probably do 99% of what you want with like 30 functions from Ramda. This is one that you would want to learn. So, with that said, thank you for spending your time with me. Tell a friend, and then I'll see you in the next video.